Okay, here is the normal distribution problem from last week's test. Problems D through F. Problem D says find the expected number of weeks in the year in which the store sells between 250 and 320 t-shirts. Now, the important language in there is this expected number. Now, what we can do is we can remember what expected amount is, and it's basically the total number of times an event happens times the probability of a specific outcome. Now, in this case, we were asked about how many times in a year you would sell between 250 and 320 t-shirts. Well, t-shirts in a week. Well, how many weeks are there in a year? 52. So that is our total number of times an event happens. 52 weeks in 1 year. Now the second part, the probability of a specific outcome. What is the specific outcome that we're looking for? Well, it's between 250 and 320. So we're looking for the probability that between 250 and 320 t-shirts are sold per week. So in order to do that, we're going to have to use that normal CDF function again on the calculator. And this time, the lower boundary is 250, and the upper boundary is 320. Again, mean 300, standard deviation 50. And what that means is basically we're finding the area between 250 and 320. So the area under the curve, under the normal distribution, is the probability that will happen. So essentially, this output from our calculator will be 0.496766 ... and that's the probability that we needed to multiply by 52. So the result is 25.8, which rounds to 26 weeks. Either answer will be sufficient. Make sure you include your units. So 26 weeks is the answer. So the next question is draw a new diagram to show K and the probability 0.9. We were told before the store sells fewer than K t-shirts per week with a probability of 0.9. So this question is different from the previous ones. The previous ones were asking you to find probabilities. Now you're asked to find t-shirts per week. So that's going to require a new calculator function, and that's the inverse normal function. Here's a diagram of it. So we can see that K is the amount of t-shirts per week, and then the shaded area represents the 0.9. So that's our diagram showing that. The next question is asking us to find K. We're going to use the inverse normal function, which is again in second bars, and then you get the inverse norm, and then you're asked for the area, and so here's the area is 0.9. That's basically saying 90% of the area under that curve, or what's a 90% probability that this will happen. And so you again are going to use your standard deviation, your mean and standard deviation as given. And the output is this 364.077. And you can round that to 3 significant figures if you like. And that's units are t-shirts per week. because that's what is on our vertical axis underneath the diagram of the curve. So that's how many t-shirts per week that a store sells with a probability of 0.9. Fewer than that amount, rather. Okay, so we found K, and we've drawn the diagram. We found K, we've drawn the diagram. The final question is find the interquartile range of the distribution. Now, we know what interquartile range means. Distribution just means the normal curve with this given standard deviation and mean. So for a distribution with mean of 300 and standard deviation of 350, what's the interquartile range? Well, this is a multi-step part. First thing we have to do is we have to remember some facts about interquartile range. The first is that interquartile range is equal to Q3 minus Q1. The second thing we have to remember is that Q3 is the 75th percentile and Q1 is the 25th percentile. What that means in terms of these diagrams is that 25% of the area underneath that curve there will be shaded, and then for Q3 it's all the way up to 75% of that area underneath the curve will be shaded. But we want to know what value that is so that we can subtract them to get the interquartile range. Well, again, just like we did in the last problem, to find K, we are going to use inverse normal. And for Q1, our area is 0.25. Same mean and standard deviation. And that gives us 266.2755 ... T-shirts per week. That's what that means. So just to show that we understand this, 266.2755 ... That's what that value is right there. Okay? Now, to do this for Q3, you're going to enter 0.75 as the area, 350 for the mean and standard deviation, and that gives us an output of 333.7244 ... Now, so we can write that in here, 327 ... and that's that value of t-shirts per week. So now we have the Q1 and Q3, so we can actually do the subtraction, find the interquartile range. So let's do that, and we go 333.2744 ... minus 266, and that the difference between those is 67.4489, and that's the interquartile range. If you want to write it to three significant figures, it's going to be 67.4, and that is our answer to that problem. Okay, good luck studying for your exams. I hope that helped.